Guys, welcome back to Quiz JAMB Chemistry online class. I'm so excited to be here to take you on chemistry. So if you are praying for JAMB Chemistry, if you are praying for exam, if you are praying for the upcoming JAMB, and you're writing chemistry as one of your subject combination, then this video will save you tons of time or stress you're going to pass through reading this topic. So in this topic, in today's video, we are going to look at quantum number. What are quantum numbers, the different type of quantum numbers, and how do they ask questions? Do you get that? They want to look at writing electron configuration. How do you write electron configuration? If, for example, that they give you an electron number of 28 and say you want to write the electron configuration, how do you do that? Do you understand? So we have to break down every single thing down in this video. It's going to be a complete class. Do you understand? To ensure that you cover everything under these two topics. I'm not only going to teach you this topic here, I'm going to give you questions. I have so many questions I'm going to give to you in this class. Do you understand? So make sure you stick to the end of this video. And if you don't have enough data to stream this video or to follow to this class, please make sure you get enough data so that you not miss out. Do you understand? Now, for those of you who ask, who may be wondering, is it only chemistry you teach in your stand here, or is it only chemistry video you upload? For now, it's only chemistry video I upload for now. But time coming when I want to upload maths and physics video, I'm still doing thorough research on that. But guess what? We learn every day in our private group. We learn maths, chemistry, physics in our private group. Do you understand? So if you are not in the private group, then you are missing a lot. Do you understand? Because where we learn most is our private class. So you don't want to be in a situation where you only learn when I upload video for you. You want to be in a situation or in a place where you can learn every single day, ask questions, we solve questions on maths, chemistry, and physics. Just that. So do well to join that private class. Just that, and it's very cheap. So from next week now, we start using our app, our CBT app for our weekend assessment test. Not for you to work very well for the exam. So do well to sign up for that private class and you'll be added to the group chat. Just so you can be learning on a consistent basis. So if you're excited to be in this class, if you're ready to learn in this class, leave at the comment section that I am ready to learn. Do you understand? Leave at the comment section that you are ready to learn. I want to see that fire. If you are ready for this class, let me see your fire on the comment section. Say you are ready to learn. Let me see those things on the comment section. Do you understand? So now let's get into it. Get down to business. So what do you understand by quantum number? Take down. Quantum numbers are a set of numbers. Quantum numbers are a set of values that describe the unique properties of electrons within an atom. These numbers help to define the electron energy level, location, and spin. Quantum numbers are crucial for understanding the electronic structure of atoms and predicting the behavior of electrons within the atom. So in our previous class, we actually deal with structure of the atom, and the atom is made up of three fundamental parts, which are proton, neutron, and the electron. Just and you see that the proton is the positively charged particles, while the electron is negatively charged particles. So now when we're talking about quantum number, now what actually determines the main properties of the atom is the electron itself. Just and that is why in a chemical reaction, that's why you see that an atom lose or gain electron. So what determines the main properties of atom is the electron. So quantum number is used to describe how electron behave. So there are four sets of quantum number. Do you understand? So we have a type of quantum number. So number one, we have called principal quantum number. Please take that principal quantum number. Principal quantum number. Principal quantum number is noted with n. So whenever I see n, when it comes to quantum number, you know what is the principal quantum number. Number two, you have the azimuthal quantum number. Azimuthal or quantum number. It's noted with L. Then number three is magnetic quantum number, magnetic quantum what number, which is what is mx. I get, well, which is n. Put it as n. Then number 4 is what is spin. Spin quantum number. Spin quantum what number, which is what x. So these are the 4 set of quantum numbers. Do you understand? So I've done a complete video when it comes to quantum number. Do you understand? But that was a little bit higher. But this video here, I want to what, tailor it down to JAMB standard, because I don't want to go beyond the scope of what JAMB, what I'm going to ask you in your exam. So this video here, although I've done a complete video, if you want to check out that video by the end of this video or lecture, I will leave it at the comments. I will leave it at the description below for you to check out the full video. Do you understand? But this video here that you're seeing here, I want to tailor it down to what you need to pass your JAMB. So if, for example, that you see any question on quantum number, you should be able to trash out that word question. Do you understand? Based on what you're going to watch now. Do you get that? So let's look at it one by one. What is principal quantum number? Now, principal quantum number is also about the energy level. So when we talk about energy level, it's not about the principal quantum number or the share. Remember, in the structure of the atom, the electron revolve around the nucleus in the shell, right? So if this is what is atom, right? So this atom have a central core, either that contain the proton and the neutron, right? Then it have something that revolve around it, which is what is the shell. This is called the shell. Either it's called the shell. So shell is also about the energy level, energy level. Idea. And this energy level is where electrons are located. It is where electrons revolve around the nucleus. Just as so when we talk about principal quantum number, is not about the share. The share of the atom is not about the energy level. It is where the electrons are located. It is where electrons revolve around the nucleus. Do you understand? And the share, which is energy level, we have what called first energy level, second energy level, third, fourth, fifth, and sixth, and seventh. Idea. So here we have the first energy level. Now the first energy level, second energy level, the third energy level, the fourth energy level, till you get to 7. Do you understand? As the energy level increases, the numbers of electrons increases. So the numbers of electrons in the first energy level is not the same as the numbers of electrons in the second energy level. And it's not the same the numbers of electrons in the third energy level. As the energy level increases, the numbers of electrons in that energy level tends to increase. Do you understand? So in the sense that n, which is the principal quantum number, can have a positive integer from 1, 2, 3, 4, 5, 6, and 7. Idea. So first energy level, please pay close attention here. First energy level, second energy level, third energy level, fourth energy level, fifth energy level, seventh, sixth energy level, and seventh energy level. Do you understand? Now, the good thing here is that each of these energy levels are denoted by by alphabets. Idea. So that is why in your chemistry textbook, after you see this one here, you see it like this. 1, 2, 3, 4, 5, 6, and 7. So the first energy level now K. The second energy level now L. The third energy level N. The fourth energy level now N. The fifth energy level now K, L, M, and O. The sixth energy level P. Then here we have the seventh energy level now Q. So here we have K, L, M, N, O, P, Q. Do you understand? Please pay attention here because they will ask questions in the exam under this. So first energy level, which is 1, is the K shape. So when you say N1, now the K shape. Do you understand? Now when I have N equals to 2, now L shape. Now when N, when you have N equals to 3, N3, now N. So as it increases, just the seventh energy level now is Q. So The number range from what is it one? The number range from what 1, 2, 3, 4, 5, 6, 7. Although they say is to what infinity, but in your standard here, to what I've seen, they stop at what at 7. Do you understand? So this is everything about what about the quantum, the what principal quantum numbers, and now it just ask you what is the maximum electron in which what each energy level can accommodate. They never ask that question in your exam. The maximum numbers of electron in which what each of this energy level can accommodate. Maximum electron, because first energy level we have its own numbers of electron, second energy level have its own numbers of electron, third we have its own numbers of electron. So if they ask here, what is the maximum electron in the what n shell? What is maximum electron in the what in the n shell? What is the maximum electron in the what in the O shell? What is the maximum numbers of electron in what in the L shell? Do you understand? So let me just give you a simple formula to do that. So maximum numbers of electron in a shell is equal to what 2n raised to what 2. So this is what simple thing here. So whenever they ask you what is maximum number of electron in what in n shell, do you understand? So the general formula is what 2n raised to what 2. Do you understand? So if I talk about n, which what k shell, right? K is what k shell. Sorry, when I say about what k shell. In k shell, that I'm talking about what the first energy level, right? That is my n is equals to what 1. So what is the maximum number of electron in what when n is 1? So you can say maximum electron is equals to 2. Now remember here we have n go to be 1 raised to what 2, right? Am I communicating here? So now going to be what 1 raised to 2 is what is 1. So 1 times 2 is what is 2. So here we have 2 electrons. 2 what electrons. Please pay close attention here because these are questions they normally ask. Right there. Now what about if I talk about what L shell? My L shell is what n equals to what n is equals to what 2, right? N is equals to what 2. Because I'm talking about n shell here, L shell, right? My n is what equals to 2. So my maximum electron here is going to be what 2 raised to what 2, right? I'm communicating here. So 2 raised to 2 is what is 4. 4 times 2 is what is 8. 8 electrons. 8 what electrons? 8 electrons. Do you understand? So let me just write this place here. Let me write this place here. Now, what about if they say n share? N share. So go ahead and calculate the mass of electron for me in the n share. In the n share, what is maximum electron? Right? So remember in the n share, my n is equal to what? 4, right? So you're going to do what? 2, 4 raised to 2, right? What does it mean? 4 times 4 is what is 16, right? 4 times 4 is what is 16. 16 times 2 is what is 32 what? Electrons. Do you understand here? So these are things you need to know under what the principal quantum number. Understand that the principal quantum number have numbers for what 1 to what 7, 1, 2, 3, 4, 5, 6, 7, right? And each of these energy level have their own alphabet of what to denote it. So the first energy level you know what K share. The second energy level you know what L share. The third energy level you know what N share. The fourth energy level you know what N share. The fifth is what is O. Sixth is what P. The seventh is Q. You must take note of these things here. And to determine the numbers of electrons in which each share can accommodate, you use the additional from 2n raised to power 2. So if you talk about K share. Do you understand? If you talk about K share, that is, I'm talking about the first energy what level, which is what n equals what 1. So you just have to impute all things here and get your answer. So please, if you understand the first, you understand the first principle, the first quantum number I've done here, leave a comment section that fully understood that I understood what you thought or what you have done in your principal quantum number. So please leave at the comment section. So because I don't want I don't want us to connect together. Do you understand? Because I'm creating this video for you and I'm trying my possible best for me to explain to you for you to understand very well. Do you understand? So if this thing is helpful and you understood the first what I've done, leave at the comment section that you understand. I want to see those things at the comment section. Do you understand? Now let's go to the azimuthal quantum number. So the next one I want to look at is called what the azimuthal quantum number, which was the L. Right there. So denoted with L. So now what do you understand by azimuthal quantum number? Azimuthal quantum number is not about the shape of the orbital. It also knows as the what? As the shape of the orbital. Just that it depends on the what? On the principal quantum number. Just that it depends on the principal quantum number. So now azimuthal quantum number ranges from L equals to what? 0 to what? N minus 1. Right there. So azimuthal quantum number is not what at the shape of the orbital, as what at the shape of the orbital. Just that because for every energy level we also have what called the orbital itself. Just that. So azimuthal quantum number describes the shape of the orbital. The orbital is where electron actually what reside. Just that is where electron actually what reside. So now n, which is what the azimuthal quantum number equals to what 0 to what n minus 1. It means that for every azimuthal quantum number, it must start from what? From 0 to what? N minus what? 1. Again, and I think that n can either be what? 1, 2, 3, 4, 5, 6, and what? And 7. Just that. So if my n is 1, is 1, again, what is the azimuthal quantum number? What are the numbers of the word azimuthal quantum number? Do you understand? So if my n is 1, what are the azimuthal quantum number? So if my principal quantum number is 1, which is what the energy level, do you understand? What are the orbitals itself? Which we also know about the azimuthal quantum numbers. So what are the azimuthal quantum numbers? So it's going to be n is equal to 0. Now because it must start from what? 0 to 1 minus 1. Do you understand? So if my n is 1, then 0 is going to be what? My azimuthal quantum number is going to be from 0 to what? 1 minus 1. And 1 minus 1 is equal to what? 0. So if my n is 1, my n is going to be what? 0 only. That is, it have only one azimuthal quantum number, which is what? Is 0. Do you understand? Which is what? Is 0. Now what about if my n is equals to 2? Remember, one is called K share, right? Do you understand? One is called K share. Now what about if my n is equal to 2? That is, I'm talking about the second energy level. Second energy level. So what will that be my quantum number? Just what will be what my quantum number, the azimuthal quantum number? So if my n is equal to 2, remember, going to be L equals to 0 to. Now remember here we have n minus 1, right? But my n here is 2. Now going to be 2 minus 1, right? So what does it mean? It means that my L equals to 0 to what? 1. Do you understand? So now let's look at something here. After 0, what do we have next is 1. So it means that my L is going to be what? 0 and what? 1. It means that my second energy level have 2 azimuthal quantum number, which are what? 0 and what? 1. On the other hand here, my first energy level, which was the K share, have only one azimuthal quantum number. That is 1 orbital. Do you understand? Which was 0 orbital. Alright, that makes sense here. So if my n, what does this mean here? If my n is equals to 1, That is my L is going to be what? 0. Do you understand? Do you understand now? Now, if my N which is what is 2, my L is going to be what? 0 and what? 1. Do you understand? So because here is formula here, 0 to what? N what? Minus 1. So now what about, let me also write this place out first. What about if my N is 3? Now what is 3? Here called the N share, right? Remember 2 is the K share, K is the N share, right? So N is equal to 3. Then I'm talking about what the M share. Do you understand? K L N. So I'm talking about the M share. Now what will be my Azimuthal quantum number? Then I'm starting from 0, right? So it will be 0 to. Now what is my N now? My N is what is 3. 3 minus 1, right? So what does it mean? It means that I would have L equals to 0 to what? 2. Do you get that? So from 0 to 2, what am I going to have? I'm going to have 0, 1, and 2. So my L is going to be 0, 1, 2, right? It means that in my M share, which was N equals to 3, only have 3 orbital, which are what? 0 orbital, P 1 and what? And 2. Do you get that? So yeah, I can just say that. Yeah, I can say that for my N equals to what? 3, which I'm talking about what? The M share, right? Now what will be my L? Then it's going to be 0, 1, and 2. If you check very well here, it follows a pattern, right? If my N is 1, what is my L? 0 orbital, which is what? Only 1 orbital. Now, then if my N is equal to 2, which is called what? The second energy level, right? What my L? What are the Azimuthal quantum number? You only have 0 and what? 1. Does it make sense? Now, if my N equals to 3, what am I Azimuthal quantum number? They are what? 0, 1, and 2. Do you understand now? Okay, now try this one for me. What about if my N is equals to 4? What about if my N is equals to 4? What about if my N is equals to 4? What my L? Now remember, N. If my N equals to 4, I'm talking about the 4th energy level. What is the 4th energy level? Remember, K L M N, right? I'm talking about what? N here. N share. N what? Share. N share. Do you understand? What are my Azimuthal quantum number? Right? It's very easy here. So it's going to be what? 0, 1, 2, and what? And 3. Do you understand? So for my N share, which was 4th energy level, which was N is equal to what? 3. N share itself, N share, right? So what do you understand? You're going to be what? L equals to 0, 1, 2, and what? Yeah, 0. Okay, 4th energy level, right? 4th energy level. So 0, 1, 2, 3, right? That is it. Now, what about if my N is equals to what? 5? K L M N O. O. That's about O share, right? The O share. Now, what is my Azimuthal quantum number? What am I Azimuthal quantum number? It's going to be 0, 1, 2, 3, 4, right? What about if my N equals to 6? P share, right? P share. So what are my Azimuthal quantum number? Going to be 0, 1, 2, 3, 4, 5. Do you understand? So you can see how easy it is now. So now the principal quantum number and the Azimuthal quantum number are related. Now before we move on here, each of these 0, 1, 2, 3, 4, they have a number or what alphabet to denote them. So If, for example, now let me wipe this out here. Now look at something here. Remember, we're talking about azimuthal quantum number. Azimuthal quantum number can be what? N equals to 0, 1, 2, 3, 4. See what? Infinity. Do you understand? Just like the way we have N equals to 1, 2, 3, 4, 5, 6, 7 to what? Infinity. Do you understand? That is the way we have one here. Now remember, in the what? Azimuthal quantum, in the principal quantum number, here we have K, L, M, N, O, P, Q, right? So this is where we stop. The same thing here, each of these one also have their own alphabet here. Now, 0 orbital is now what? X orbital. 1 orbital is now what? Is as P orbital. 2 orbital is now what? As D orbital. 3 is now what? As the F orbital. 4 is now as what? As G orbital. Do you understand? So here you can write like this. Please pay close attention. So now whenever you see 0, 1, 2, 3, I there. So the most common one you will see in chemistry at our level here is going to be 0, 1, 2, 3, which are what? S, P, D, what? F. Please understand this here. S, P, D, F. So 0 is now what? The X orbital. 1 is what? Is now what? P orbital. 2 is now what? As D orbital. 2 is now what? As the F orbital. Do you understand here? So now, let me make more sense to you. You get, I want to watch relate the two of them now. So remember, if my N is equals to 1, right? What is my L? My L only have what? 0, which is called the X orbital. Do you understand? X orbital. Do you understand? If my N is equals to 2, right? What is my L numbers? 0, 1, which are what? X and what? P, right? If my N is equals to what? 3, what is my L? 0, 1, 2, right? So which are what? X, P, D. Do you understand here? So if my N is equals to 4, what is my L? 0, 1, 2, 3. Which are what? S, P, D, what? F. Can you see that? So now, when you combine them together here, okay, now let's start from here. When you combine this one here, going to be what? 1x. That is, this one means what? My what? Energy level. X means what? My orbital. So my first energy level only have what? X orbital. Do you understand? X orbital. So that's why we have 1x. Now, if you check this one very well, it's going to be what? It's going to be what? 2x 2p. Now, what does it mean? That second energy level, which one is what? Now, first energy level is now what? K share, right? K share have what? X, which is called 1x. After the K share is what? Is KL, is L share, right? What? Energy level 2. It have what? S and P. We have 2x 2p. Do you understand? Now here you're going to have what? 3x 3p 3d. Do you understand? Here you're going to have what? 4x 4p 4d what? 4f. So look at something here. Chemistry will only end at what? At the x at what? F orbital. So it does not go further. Just like it does not go what? Further. It does not go further. So this is it here. Do you understand? So if you understand the second one here, leave at the comment section that you fully understood what I've done in what Azimuthal quantum number. You can see that the way we are taking what step by step for you to what understand this concept here. Do you understand? So this topic is one of the most difficult topics when it comes to chemistry. So that's why I'm taking what step by step for you to understand. So this is everything about what the Azimuthal quantum number. So the next one I want to look at is what magnetic quantum number. So let's look at what the magnetic quantum number. So now let's look at what magnetic quantum number. Now when we talk about magnetic quantum number, it's not about suborbital. Just that we have x orbital, right? X orbital. Now, which is what? 0, right? Here we have p orbital, which is what? 1. Here we have d orbital, which is what? 2. Here we have f orbital, right? F orbital, which is what? Is 3. So here we have 0, 1, 2, and what? And 3, right? So 0 orbital, the number is what? S orbital, the number is what? 0, right? P orbital, the number is what? Is 1, right? D orbital, the number is what? Is 2, and F orbital, the number is what? Is 3. Understand this here? Do you understand? Now, so now we're talking about magnetic quantum number. Magnetic quantum number is also known as the suborbital. Each of these one have their own suborbitals. Do you understand? So now, the magnetic quantum number depends on what? On the azimuthal quantum number. Do you get that? So when we talk about magnetic quantum number, it lay emphasis on the azimuthal quantum number. Okay, so when we talk about magnetic quantum number, here the formula here, minus L to 0 to what? Plus L. Okay, now what? Suborbital. Okay, sub what? Orbital. Do you understand? So this is what you want to understand here. So how many suborbital does X have? How many suborbital does what? P have? And how many suborbital does D have? And how many suborbital does P, does F have? Do you understand? So if my n is what? Is 0, because if you are talking about S orbital, I'm talking about 0, right? The quantum number is what? 0. Now what? Sorry, if I talk about L, which is what? Is the what? Is the azimuthal quantum number, which is what? 0. If I talk about 0, I'm talking about x what? Orbital, right? X orbital. What my n? My n is what? Because they say it must start from the negative value of the what? Azimuthal quantum number. And my L is what? 0. There's no way I can have minus 0 to plus 0. Do you understand? 0 is just 0. So that is going to be what? 0. Do you understand? It's going to be what? 0. Now, it may not make sense to you now until you move to the other one here. So if my L goes to what? 1. So if I'm talking about 1, I'm talking about P orbital, right? P what? Orbital. Does it make sense to you? Now, what my M? My M, because look at something. What is M again? M, for you to get M, you must start for the negative value of the L to 0 to what? To the positive value of the L. You understand? So if I take L to be 1 now, which is going to be P orbital. What my magnetic quantum numbers? What are my magnetic quantum numbers? What are the suborbitals? So because here we have 1, so going to be what? Minus 1. After minus 1, we have what? 0, right? After 0 here we have what? Plus 1. Do you understand? Now, it may not make sense to you now until you level to the other one. Yeah. If my L is equal to what? Is to 2. And 2 is what? Is D what? D orbital, right? D orbital. What be what? My N. Right there. Remember, I'm going to start for what? For minus M from minus L to 0 to what? Plus L to get what? My M. Do you understand? So it means that I'm going to start for what? For minus 2. Now, if I move from minus 2 to 0 to the positive value, what is next thing here? I'm going to have what? Minus 1, right? After minus 1, what is next thing? Here I'm going to have what? 0, right? After 0, I'm going to have what? Plus 1 or plus 2. Do you understand? Do you understand? So that is it. So D orbital have what? Minus 2, minus 1, 0, plus 1 or plus 2. Do you understand? So if my L is equal to what? 3, which is what? Is the what? F orbital. F orbital. My M will be what? Minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Do you understand? Now let me break it down for you to understand here. It means that if my L is what? 0, then X orbital, I'll only have one suborbital. That is meaning. This means that only 0 orbital. Do you understand? Suborbital here. Then X orbital only have one suborbital. Do you get that? Now p orbital have 3 suborbital, 3 minus 1 0 and plus 1. This that minus 1 0 and plus 1. D orbital have what? 1 2 3 4 5 5 suborbital. 1 2 3 4 5 minus 2 minus 1 0 plus 1 and plus 2. This is that. Then F orbital have what? 7 1 2 3 4 5 6 7 7 1 2 3 4 5 6 7, which is what? Minus 3 minus 2 minus 1 0 plus 1 plus 2 and plus 3. Do you understand? So now, but like I said, I'm going to tailor this class to your JAMB standard. So I'm not going to go beyond what you are supposed to learn in your JAMB. Do you understand? So once you gain admission to year one, as you move further in chemistry, you start exploring this thing more. You get? So it means that I'm going to summarize what I've just done here. Do you get that? I'm going to summarize everything I've just done here. So you have to take it down. So let me just summarize everything I've just done here. Some here, X orbital only have 1 suborbital. Do you understand? P orbital only have 3 suborbital. D only have what? 5. 1 2 3 4 5. Then F orbital have what? 7. 1 2 3 4 5 6 7. Now, another thing you want to take note here is that, please understand this here. Another thing you want to take note here is that each of these orbitals can only accommodate, each of these suborbital can only accommodate 2 electrons. Do you understand? Any suborbital you are seeing here can only have how many electrons? 2 what? Electrons. So these can only accommodate 2 electrons. 2 what? Electrons. 2 electrons. Do you understand? This can accommodate how many electrons? This can accommodate 1 2 3. 2 to make it what? 6 what? Electrons. 6 electrons. Now this can accommodate 1 2 3 4 5. Here can reach what? 5 times 2 is what? Is 10 what? Electrons. Do you understand? Electrons. Then this F can accommodate what? 14 what? 14 what? Electrons. Now let me explain to you again. Now X, the maximum numbers of electrons X orbital can accommodate is what? Is 2. Now because they will ask you in your exam, the maximum numbers of electrons S is what? In S is what? Is 2. Now what about the maximum numbers of electrons in P? Is 6. The maximum numbers of electrons in what? In D is what? Is 10. And the maximum numbers of electrons in what? In F is what? Is 14. Why? Because these only have 1 suborbital. These have what? 3 suborbitals. These have what? 5 suborbitals. These have what? 7 suborbitals. Do you understand? So this is what you need to know when it comes to what? Magnetic what? Quantum number. Do you understand now? Magnetic what? Quantum number. You learn about spin quantum number. What about spin quantum number? Now, spin quantum number just deal what with the orientation, right there. So, in spin quantum number, electron either spins up or it spins down, right there. That is it. Electron either what spins up or what spin down. That is what we call spin quantum number. So remember, for each suborbital, they are what 2 electrons. So now in this one here, electron either spins up or spins down. Now when the electron spins up, it's not what minus, it's not what plus half. And when it's spin down, it's not what minus what half. So it's not what the orientation of what of the electrons in the what suborbital itself, where it contains or where it is be found. So when it spins up, it's not what plus half. When it spins down, it's not what minus what half. So this is what you need to what take note of. So now let's have some typical questions when it comes to what quantum number. Before moving to the class properly, now let's look at what the first 2 questions about quantum number. Just although there are some other questions we want to talk about as progress. Now, first of all, let's look at these 2 here. They say that the first one is this: the maximum numbers of electrons that can be accommodated in a sublevel, which L equals to 3 are. So he said that what is the maximum numbers of electrons when my L is what is 3? Now, what's my L? My L is what is Azimuthal quantum number, right? So please pay close attention here. I'm gonna show you 2 ways to get this question to get the answer here. You get that? There are 2 ways just to get this answer here. So if my L, so remember my L equals to 0, 1, 2, and 3, right? And my 0 is what is the X, my 1 is what is the P, my 2 is what is the D, my F is what, my 3 is what is the F. Do you understand? So if I'm talking about my L equals to what 3, I'm talking about the F what orbital. Do you understand? So how many electron can be found in the what F orbital? How many electron can be found in the F orbital? That is the question. That is what is the question. So remember, X equals to what 2 electrons, right? Now P is equals to what 6 electrons, right? Now D equals to what 10 electrons, and F equals to what 14 what electrons. Do you understand? Now with this one here, because we're talking about L equals to 3, so what is the maximum number of electrons in the one in F orbital? Is what is 14 what electrons right there, which is what is the D, right? Which is what is D. Do you understand now? So we have already done this thing as I was explaining what the magnetic quantum number. Do you understand? Now, but we have a general formula right there. So maximum numbers of electrons in sub-level, in sub-level, right there. Maximum numbers of electrons in sub-level is equals to what? 4L plus what? 2. Is okay? 4L plus 2. So this formula is very easy for us. So you just carry what the one the yellow gave to you, which is what L equals to 3, and place it here. Just so if you should place it here, going to be what? So if my L equals to what 3, let's say you go to correspond to this 14 here. What are we going to have? Going to be 4, 3 plus 2. 4 times 3, which is what? 12 plus 2, which is what? 14. Do you understand? So it corresponds. So the answer is what is 14. Now let's test strong. Yeah. Now let us say my L is equal to 0, because L starts from 0 to what? T 3 or 4, 5, right? So what about if my L, because let me just confirm this stuff for you here. Do you understand? So if I'm talking about 3, I'm talking about the F orbital. If I'm talking about 2, I'm talking about the D orbital. If I'm talking about 1, I'm talking about what the P orbital. If I'm talking about 0, I'm talking about what the X orbital. Do you understand? So if I say my N is equals to 0, the maximum electron, maximum what electron is what? Maximum electron is equals to what? 4, 0 plus 2. 4 times 0 is what? 0 plus 2, which is what is 2, which is this one here. Do you understand? So it corresponds, what I say is 1. Put 1 here, right? 4 times 1 is what? 4 plus 2, which is what? 6. So and 1 is what is the P orbital, which is corresponding to 6. Do you understand? So whenever you see a question like this, it should be a bonus mark for you. So let's go to question number 2. Please, now before we continue, if you know that you have not subscribed to this channel, the only way you support what I'm doing here is for you to like and subscribe. Not only subscribe, turn on the notification bell, so whenever I upload a video on mass chemistry and physics, you will be sent a notification that video will be uploaded. You should go and watch the video here. Do you understand? So that will make things much easier for you. Like what I said, if you have not joined our private group chat, please endeavor to join our private group chat, because time will come when these videos will not be free again. As exam time move on, you are not, these videos will not be free. Only those who have paid for the class will be able to access the full video. Do you understand? So that is what is the advantage. So please make sure you subscribe. Leave at the comment section if this video is helpful so far. Please leave at the comment section that this video is what is helpful. So let's move to what question 2. Question 2. So what is question 2? They say that if both K and L shell are filled, what will be the atomic number of that element? So here we have what K shell, and you have L shell, right? I tell that the maximum number of electrons in the shell, maximum numbers of electron in shell is what 2 n raised to power 2, right? K shell is what n equals to what 1, right? And L shell is what n equals to what is equals to what 2. Please pay close attention here. K shell, now we talk about K shell. We talk about the first energy level, which is what n equals to 1, right? We talk about the L shell. We talk about n equals to what 2. You get that? So what is maximum electron in this L shell here? So it's going to be 2 1 raised to power 2, right? And here we have 2 raised to power 2, right? So 1 raised to power 2 is what 1 times 2. Here we have 2 electrons. 2 electrons, right? So this is when it is being filled up. What about this one here? 2 raised to power 2 is what is 4 times 2, which is going to be your 8 what electrons. 8 electrons. Do you understand? That's one numbers of electron. Now I say that if both K and L shell are filled, what will be the atomic number of what of the elements? So you just have to add the 2 of them. So when you sum 2 of them, so really 2 plus 8, which is going to be what 10, right? So yeah, C is what is the answer. So you can see how trickish they might likely ask question on. Do you understand? So you have to take note of all these ones. Yeah. Right? So that is what for the quantum number. So let me go to the electronic what configuration. How do you understand electronic what configuration? So let's look at it. Okay, now how do you write the electronic what configuration? So now let me break it down for you to understand, right? So now the first you want to understand here is what is the orbitals x, p, d, f. So that's the first you want to take note of here, right? So x orbital. Now, the numbers of electrons S calculated is what is 2 electrons, right? 2 what electrons. P is what is 6 what electrons. 6 electrons. D is what is 10 electrons. Then F is what is 14 what electrons. 14 electrons. Very important, right? Now, before you can write the electronic configuration of any element at all, first of all, you must understand what a simple system, which I'm going to explain to you now. Now, with this simple system, you don't need to cram anything here. Now, one of the reasons why majority of chemistry students don't understand chemistry at all is that they are trying to know chemistry by cramming. You don't understand chemistry by cramming. You understand chemistry by taking down every single thing, understanding what the fundamentals. So, in my channel, I don't teach you to cram chemistry. I teach you what the fundamentals, so you'll be able to understand the concept very well. So, whenever any question is being asked, you'll be able to answer that question. Do you understand? So now, how do you write any configuration? Now, please take note of the system here. Remember, we have energy level, right? For 1, 2, 3, 4, 5, 6, 7, right? And have these 4 orbitals. Do you get that? So to write the electronic configuration of any element at all, please pay close attention. Here is the simple system here. So you have 1, 2. So it's going to be 1x, 2x, 3x, 4x, 5x, 6x, and 7x. Right? So it's going to be from 1 to 7. Do you get that? So we are done with what with x. Now let me go to p. P, we are not going to start from this one here. We want to start from 2. So we're going to be what? 2p, 3p, 4p, 5p, 6p, and what 7p. Right here. So we are done with this guy here. So let me go to D now. D, we're not going to start from here. I want to start from here. 3d, 4d, 5d, 6d, and what 7d, right? So let's move to F. F here, we're going to have what 4f, 5f, 6f, and what 7f. Do you see that? So the next one to do here is what is to draw an arrow. So it's very easy here. So draw the arrow from here. Do you understand? It's very easy. Draw the arrow. You don't need to force it here. So draw the arrow. You see that it will just enter. Draw the arrow here. Draw the arrow here. Then draw it to this point. To this point. to this point and to this point. Do you understand? It's very easy. It's very easy. You can do it. You can do it. So now you can see the direction of the arrow here is pointing up, right? So if you take one here, point up. So you have 1x. Can you see that? So point up 1x. Next is what is 2x. 2x. So next is what? After 2s, you have 2p, 3s. 2p, 3x. Can you see that? Next here, you have 3p, 4x. Can you see that? Here we have 3d, 4p, 5x. Can you see that? 5x. So what do you have here? After this here, what do you have here? Here we have 4d, 4d. Here we have what? 5p. Here we have what? 6x, right? 6x. And what do you have here? We have what? 4f, 5d, 6p, 7x. So that's how you do it. You get what? 7f. You see that? Now, but guess what? At this level here, you will only get to probably the highest is what is 4d. Highest is what is 4d. So, but the science here, this is what you use to write electrical configuration, which I'm going to teach you now. I'm going to teach you this thing. It's very, very easy. You get it? It's very, very easy. So, this is how to do it here. So you don't need to cram it here. If for example now you want to write any configuration and you cannot actually know it here, but you should know from 1x to what 4d. So here we have 1x, 2x, 2p, 3s, 3p, 4s, 3d, 4p, 5x, 4d. Do you understand? So you should know from here to here because that is what is the maximum. That is what is the maximum. Most times they don't cross more than this 3d. Do you understand? So here we have after 4x, here we have what 3d, 4p, 5x. Do you understand? So now let's start taking some technical questions. Let's start taking some questions here. So I'll write some down, right? So I can start taking questions. Let's say what the first three set of questions. Now you say that how many electrons are in the Earth shell of this? You understand? How many electrons are in the Earth shell? Do you understand? So the first one to do is to write the electron configuration of this phosphorus. Now, when you want to write the electron configuration, you use what? The atomic number either or the electron number. Do you understand? This one is a neutral atom here. Do you understand? A neutral atom, the proton number and the electron number are the same. Do you understand? So when you talk about 15, since it is a neutral atom, please pay close attention here because this one and this one are not the same thing. I will explain to you. So this guy is a neutral atom. Now, whenever you have a neutral atom, for example, here we have X, here we have 20, and here we have 40 here. And they say you what write the electron configuration of this guy here, right? It's a neutral atom. So my electron number is what is 20, right? So now let's write one first. So now, how do you write the electron configuration when the electron number is what is 20, right? So we start from here. So now we have to feed the electron one after the other. See, we exhaust what our 20 electron. Just now. So I want to start from 1x. Remember, x can be what? How many electrons? 2 electrons. So like I say, s is what is 2 electron, p is what is 6 electron, d is what is 10 electron, and f is what is 14 what electrons. Do you understand? So now I'm going to start from here. So yeah, I'm going to start from 1x2. It's okay. So out of the 20 electrons, I've used what? 2 electrons because s can only accommodate 2 electrons. Now you cannot say 1x what 4. It's not possible because s cannot accommodate more than 2 electrons. So now whenever I see x, understand that you can only accommodate what 2 electrons. So here we have 2 electrons, which is what is 2. Do you understand? The next thing now, out of the 20 electrons, I've used what 2 electrons, so I have 18 left. So let's go to the next one, which is what 2x2, right? 2x2, right? Nice one. Then I've used 4 electrons, so I still have 16 left. Next one is what 2p. P can combine how many electrons? 6 electrons. So here I have what 6 electrons. So 2 plus 2, 4 plus 6, which is 10. So out of the 20, I have used what 10 already. Do you understand? So I'm now supposed to the next one, we got 3x. So here we have 3x2, right? 3x2. So that is 12 now. Next one is what? 3p6, 3p6. If you check very well here, 12 plus 6 is what is 18. Then I have 2 electrons left. 2 electrons left. So what are the 2 electrons? So the 2 electrons will move to what? 4x. 4x2. Do you understand? So from here to here, I've exhausted what my 20 electrons. So this is where I will stop. Do you understand? This is where I'm going to stop now. As easy as that. Do you understand? So this is the electric configuration for this element here. Do you understand? So it just ask here, how many electrons are in the L shell? Remember, L shell means what? When we talk about L shell, what here we have K shell, right? How many electrons are in the K shell? How many electrons are in the L shell? And how many electrons are what? KLM, M what? Shell. And how many electrons are what? KLM, N what? Shell. Right there. So now share, now this K share means what? The first energy level, N equals to what? 1, first energy level, right? This N share means what? N equals to what? 2, second energy level. This N share means what? N equals to what? 3. And this K L M N here you have what? This N share means what? N equals to what? 4. Right there. So now let's look at the first energy level, which is what? The K. I only have 1 energy level here, right? So my K share, it only have 2 electrons. Do you understand? Which is what? 2 what? Electrons. 2 what? Electrons. Do you understand? Now, L share, if you look at the L share, look at L share here. L share is what? 2 energy levels. So let's look at what 2. We only have 2x and 2p. So you have L share. L share. Now, we have to what? Sum the two of them. So it will be 2 plus 6, which is what? Is 8 what? Electrons. Do you understand? Please, these questions are from JAMB past questions, so you have to take note of them. Now, what about M share? M share is what? Is third energy level. Third energy level. Third energy level. So my third energy level here is what? Is 2 plus 2. 2 plus 6. So which is what? M share. M share. M share, which is what? K 3x 3p. Third energy level, right? So I'm going to sum the electron, which is going to be 2 plus 6, which is what? Is 8 what? Electrons. Do you understand? Now, what about N share? My N share, my N share only have 4x. So which is what? 2 what? Electrons. So these are type of questions you were expecting in your JAMB examination. Do you understand? So get what they're asking you what in the first year. How many electrons are in the L share of what? P. So you have to write the electric configuration of P. Then move to the L share, which is 2. Add the electrons together. Can you do that? So if you can do that here, I want to tell me the answer for what? For this one here. Is it A, B, C, or D? Now let me hear from you before we do it together. Yeah, let's look at what it is very well. So here we have P, here we have 31, here we have what? 15. So here we want to write the electron configuration first. So let me write this place here so there won't be any confusion. So here we have this one here. So P. So we need to write the electric configuration of this guy here, which is going to be what? 1x2, right? Here we have 2x2, right? Then we have what? 2p what? 2p what? 6. So making how many? 10 electron. So 15 minus 10, we still have 5 more, right? So what is the next one? The next one is what? Is 3x what? 2, right? 3x2. So which is 12. How many do you have left? Is 3. So we're going to do what? 3p3. Do you understand? So this is what is the electron watt configuration. Now, but what did they ask us to look for? They said that how many electrons are in the L shell? L shell means what? Second energy level. So this is what second energy level here. 2 and 2. And 2 only have X and P. If you look at the electron, 2 and what 6. So you don't just sum the electron together. So numbers of electrons in L shell, in what L shell, go to be what? 2 plus 6, which is what? 8 what? Electrons. So the answer is what? Is C. Do you understand? That is it. So number 2, they say, what is the valence shell electronic configuration of the element with atomic number of what? 17. Atomic numbers of 17. What is the what? Electronic configuration. So you can pause the video and try. We have already done for try. So this one here is what? Maybe you are saying X is 17 now. They say you want to write the electronic what configuration. So let's do it like this. X17, right? X17, the electronic configuration. How do you write the electronic configuration here? So here we want to start with what? 1x. So we only do what? 1x2, right? Here we have what? 2x2, 2p6. Is okay. 1x2, 2s2, 2p6, right? What is the next one? 3x2. So which is what? 12. So 17 minus 12. I have what? 5 remaining. Just and so here we have 3p5 because p calculated us selection, but we only have 5 remaining. So now let's count it here. 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 5 is what? 17. Just as so this is what electronic what configuration. So now let's look at what the third one. It says that the electronic configuration of magnesium 2 plus. So this guy is what? Is an ion. So now when I say a plus, it means that it has what? Lost 2 electrons. Do you understand? It has lost 2 electrons. So let me write this place out. Let me write this place out here. So now when I see Mg2 plus, so you have Mg2 plus. Idea. Now magnesium is what? Normally the atomic number is what? Is 12. Idea. Now but here it has lost 2 electrons. Do you get that? Now that is why I say that you should watch. Make sure you go watch our first video. It's very, very important. Make sure you go check out the first video. Make sure you check out the first video on what situation of the atom. Do you understand? Because here they ask you what is the electron number, what is the proton number, what is the neutron number. Do you understand? So from here now, my electron number. So my electron number is going to be 12 minus 2, which is going to be what? 10. So then guys, whenever you're writing electronic configuration, you use what? The electron number, not the atomic what number. Do you understand? So that is 10 I'm using. So I'm going to be what? I'm going to start what? With 1. 1x2, right? 2x2, right? 2p6. So this is it. This is the answer here. So the electronic configuration of magnesium 2 plus is what? 1s2, 2s2, 2p6. Why? Because it has lost 2 electrons. Just like it has lost 2 electrons. So this is the what? This is the what answer. So there are still a bunch of questions we need to answer here, but I've already exhausted all the time on this video. In this video, I've already exhausted all the time here. Do you get that? So if this video is helpful, please leave in the comment section that this video is helpful. Now we are still going to solve a bunch of questions now, because after this video here, we are moving to our private class where I want to solve variety of questions. I want to solve variety of questions like. So let me now show you some of the questions. So now these are the type of questions we also see, and these are the questions we have to answer in what we have to do in our private group. It's not everything I can post here. Do you understand? Because those people who paid for a class should benefit more. Do you understand? So now I believe I've done my best for you. Do you understand? But if you want to learn, more, you should join the private class. The private class is just 15,000 naira for maths, chemistry, and physics. Now, for those of you who will complete that 50,000 naira is too much. if 9,000 naira is too much for you, then it's like you don't know the stress you need to pass through for you to cover these things here. I bet you, as me is not for this class you are seeing now, this free class you are seeing now, there's no way on earth you should be able to cover all what you have covered today. So that is advantage. So in our private group chat here, you have access to unlimited resources and materials. Once you pay your money, now once you pay your money, you have what? You have access to our free app. You do get that. So because in the app, that is where we conduct our mock tests every single week. Every single week we conduct what mock tests on maths, chemistry, and what physics. So you're not only learning, you're also applying you're also applying learning how to answer questions in the exam. So this is the advantage. So you benefit more when you join the private group chat. You have access to our maths video. I don't for now I've not started posting maths and physics video, it's not possible. So these are our premium contents. Just and so this chemistry is just like the free video I can do for you. But if you really want to enjoy the class, if you want to prepare very well for the class, then join the private class. You understand? DM me, say you want to join the private group chat on the comment section that you want to join the private group chat. Please, if you are coming to tell me that you want to pay for, you want to join the private group chat, please make sure you have your money ready. You understand? Make sure you have your money ready. So I want you to chat me, you give my number, you chat me up, then you pay, you join the what? You join the private group chat. Do you understand? So I wish you success in your preparation. You understand? Don't think that you can do it alone. That is why you need to join the private group chat. If this video is helpful, please leave a comment section that this video is helpful. Please always share this video to other persons that want to join the class and that will be of help to them. Do you understand? Thanks for watching. See you in my next free class.